Hi everyone, welcome to my video. If you have been following my previous video, you know that I am doing a course on UPSC previous year's question paper. So in this video, I will discuss Civil Service Men's 2021 question paper 2 one by one. So first section question number here. Question number A. Find the minimum magnetic field needed for the Zeeman effect to observe in a spectral lines of 4 nanometer wavelength when a spectrometer whose resolution is 0.0110 nanometer is used. Write the answer of nearest height integer. And question number 1b. Normalize the wave function of a hydrogen atom for first state is sine 100 is equal to 1 by under root pi a naught q e per minus r is 0, where a naught is equal to h cut square by me. Being the bore radius, calculates the expectations value of a potential in this state. And you can see this: a beam of 12 electron volt electron is incident on a potential barriers of a height 25 electron volt and with 0.05 nanometers. Calculate the transmission coefficient. So you have given that this is the given data. So exponential and hyperbolic functions. And question number D is here. Calculate the Lemma precessional frequency for a magnetic induction field of 0.5 t. Hence, the calculator splitting in a wave numbers of the expected line due to the normal Zeeman effect for the same field. Question number is: the first lines in a pure rotational spectra of HCl appear at 21.18 cm. Calculate the bond length of the molecule. Give the atomic masses of H and Cl are 1.008 and 35.45 AMU electron mass unit respectively. And question number 2a. This question, this and this. So use Pauli spin matrix, prove that. So according to Pauli exclusion, and prove that. And question number B is here. Find the uncertainty in the momentum of a particle when its position is determined with 0.02 centimeter. Find it also uncertainty in the velocity of an electron and alpha particles respectively when they are located with 15 into 10 power 8 centimeter. Question 2c. A particle is moving in a one-dimensional box of width of 15 angstroms and infinite height. Calculate the probability of find the particle within interval of 15 angstrom at the center of a box when it is in its state of least of energy. And question number 3a. In observing Raman spectra of a simple using 3617 angstrom as in the exciting lines, 1. Get stock lines at 3980 angstrom. Reduce the Raman shift in a meter unit. Compute the wavelength in MV angstrom of corresponding stock and anti-stock lines. If the exciting lines is 6465 angstroms. And question number 3b is here. Explain spin orbit coupling. Discuss the splittings of spectral lines of hydrogen atoms due to spin orbiting couplings. Question 3c is here. The quantum number of 2 electrons in a 2 valence electron atoms are N1 is equal to 8, L is equal to 4, S1 is equal to 1 by 2, N2 is equal to 7, L2 is equal to 2, S2 is equal to 1 by 2. First, assuming LS coupling, find the possible value of L and hence of J. Assuming JJ coupling, find the possible value of J. And 4 is here. A particle of a rest mass m0 has a kinetic energy k, so that is a de Broglie wavelength is given by. So lambda is equal to SC by under root k plus 2 m0 c square. Here, calculate the wavelength of an electron of a kinetic energy 2 mega electron volt. What will be the value of lambda if k is less than m0 c squares? 4b is here. Calculate the probability of the finding of a simple harmonic oscillator with the classical limit if the oscillator is in its normal state. Also show that if oscillator is in its normal state, then the probability of finding the particles outside the classical limits is approximately 16. Question number 4c. Describe the normal and anomalous Zeeman effect. Explain how is left of diagenery in a hydrogen atoms. Question number section B. Question number 5a. In X-ray beams of wavelength lambda 1 undergoes a first order Bragg reflection at a Bragg angle of 13. X-ray of wavelength 97 Nm undergoes third order reflection at a Bragg angles of 16. Consider that the two beams are reflected from the same sheet of fleece. Find the value of lambda 1. 5b is here. Using the expression for internal energy, U is equal to 3n h cut omega E h cut omega by kVt per minus 1, so that the Einstein specific heat capacity is given by. So C is equal to 3r h cut omega kt equal to square E per minus h omega kVt E h cut omega kVt minus 1 whole square. Also, so the Einstein specific heat capacity given above, it proportionals at E per minus h omega kVt at a very low temperature. Question number 5c. Rho and k meson both decay mostly to pi plus and pi minus. Explain why the means of lives of rho are shorter proportional 10 to the power minus 3 compare with the lifetimes of k approximately 100 10 to the power minus s. Question number 5d. What are the property of the particle made of following the quark? UD, UDDS and USS. And question number 5e. What are the chain reaction? What do you mean by critical size of the core which chain reaction are take place? And question number 6 is, what is the importance of the study of deuteron? Obtain the solution of Schrödinger equation for a ground state of deuteron, so that deuteron is loosely bound of systems. Question number 6b is, so that in the nuclear cell model is the level spacing between the major oscillator cell is approximately h cut omega is equal to 41 a per minus 1 by 3 mega electron volts. And question number 6c. How many types of neutrino exist? How do they differ through their masses? And question number 7a. A NPN transistor with beta is equal to 49 is used in a common emitter amplifier mode with BCC is equal to 10V and RL is equal to 2K ohm. If the 100 kilo ohms resistor is connected between the collector and the base of the transistor, calculate the quiescent collector current assuming VB is equal to 0. And question number 7b is here. In the metallic state of a transistor, metal scandium has a single electron in 3D subcell. Calculate the value of a total angular momentum J and the land splitting factor J, and use this value to determine the energy of the lowest energy dipole moment in a field of 0.5 t. 7c. Question number. Calculate the pinch of voltage for a n-channel silicon FET field effect transistor with a channels width of a 16 to 10 to the power 4 cm and a donor concentrations of 10 to the power 15 cm given the dielectric constant of silicon is 12. And question number 8 here. 8a. You can see this. and sketch the DC load line for the circuit. So and question number 8b, a solid contain a dilute concentrations of Nd3 plus ions, each of which process there are 4f electron. Assuming that there are 25 meter cube of these ions, calculate the magnetic susceptibility of the sample at 1K. And question number 8c, explain the phenomenon of internal conservation and define the internal conservation coefficient. Discuss the under what condition does the internal conservation process becomes the important. So that is all related to this discussion. It for today. Thank you very much.